Awesome. It's great to be here. I'm Morgante. I'm the founder of Grit, and we build reliable AI agents for software development. I'm not sure. Okay. The problem that we work on is that developer productivity is not just writing code, right? It's not just creating brand new code. It's debugging old code. It's updating code. It's modernizing things. Stripe did a survey a few years ago, and the biggest causes of developer productivity, a huge time is spent dealing with legacy code, right? A third of the time is spent just refactoring, updating old code. I think everyone who's a developer.
You have to use this.
We're switching mics here. Hopefully less feedback there. It's good. Cool. So this is really unfun, right? Nobody wants to spend time schlepping through an old code base to update something, deal with that. It's the least interesting thing a developer could do. I've had to do it many times in my career. I never liked it, right? This is only getting worse, right? With Copilot and other tools, the marginal cost of a new line of code has gone to zero, right? You can have autocomplete that will generate thousands and thousands of lines of code in a few seconds, right? But the cost of maintaining that code hasn't been changed that much, right? Every line of code that you add into your code base is something that has to be maintained over time. It has to be tested, it has to be validated, and we're basically just accruing lots of debt at a really fast pace, right? You still have to keep that updated, and there's potentially security vulnerabilities that come with that. There's just honestly the mental overhead of dealing with understanding code bases that are millions and millions of lines of code that we're increasingly seeing every company have. So with Grit, we like to use an AI to deal with this code, right? Just like you have an AI that helps you generate brand new code with Copilot, you should have an AI that takes care of maintaining your old code, right? And this is great because this is something nobody wants to do, right? But the AI is happy to be patient. It's happy to spend hours, days, weeks just schlepping through old code, looking for things that need to be fixed, and just monotonously doing it every time, right? Every time you're using a deprecated method, every time you're using an old API, every time that you're using something that's potentially insecure but was a little bit faster to write, every time you're not checking for a null pointer, right? The AI is happy to go through all that old code, fix it, and make sure it's all as though it was written brand new. It's also very thorough. It's not going to make the same kind of mistakes a human would, right? On the third hour of refactoring, for taking a shortcut and forgetting about something they should have done anyways, right? And of course, it's steerable, right? This is actually one of the biggest things we've seen from our customers is that even if they have programs in place to make code consistency, to try to refactor old code, it's really hard in an organization with maybe hundreds or thousands of engineers to get everyone on the same page, right? To make sure that everyone's taking the same exact approaches, right? Whereas in AI, you can actually just give it instructions, and that's going to apply across the board no matter which team you're on. We've got customers that have 8,000 different developers who are all trying to coordinate, and the AI is actually the first time that certain insights from one part of the organization were surfaced back up through Grit making suggestions that the other part of the organization did. And of course, it's much faster and cheaper, of course. It just always comes down to the business value too. Cool. So there's three core challenges that we had to solve with building Grit. Search is the biggest one, right? So if you've got a code base that has 10 million lines of code and you're trying to get rid of an old API or you're trying to refactor something, where do you even find the relevant parts, right? Tools like language models have gotten really good at giving a small, narrow problem, changing it, right? You can give it a component or you can give it a single function and ask it to refactor it. ChatGPT will do that all day, right? What it won't do is look at 10 million lines of code and tell you the 50 that have to change as part of a particular issue, or if an API is being deprecated. And this is what Grit really excels at. We built a tool called GritQL, which is a query language for indexing and scanning massive code bases and essentially making SQL queries on top of it in a declarative syntax, and then actually doing those transformations. Once you start to do transformations, correctness is another big problem, right? How do you validate that a change is correct without having to do extensive manual testing and without having an engineer go and review every single one of those 10 million lines of code, right? It's not something that anyone wants to do code review on either, right? So that's where we've had to spend a lot of time on making sure that code correctness is in place without actually spending time doing that manually. And then consistency. I was talking about how you make sure the code base, you're applying the same refactoring techniques, the same fixes each time, versus trying to develop new ad hoc ones each time, right? And this is something where AI does a much better job than humans actually. So yeah, talking about search for a second, what we do with GritQL is index the entire code base the same way a compiler does understand the abstract syntax tree, and then can take a natural language prompt or some human input, convert that into a compiler understanding, right? So we're not going to just search for the text. We're actually going to search on the compiler level for matching code that is similar to that or follows the same conventions, and then feed that back into our model, right? So this is just a quick example. If I was trying to look at every time I'm doing console.log or console.error, we can convert that into the AST representation and then search across the board. Once we've finished with search, then you have to start to make changes. So this is our overall agent architecture. I'll show you a demo in a minute, which is probably more interesting to see than this slide. But we first make any changes, right? We use the indexing, the GraphQL query engine to figure out where in this 10 million line code base do we have to make changes, right? Go in, make those initial changes. But this is always just our first pass, right? It's almost never correct on the first pass because understanding every nuance in a huge code base is hard, right? Even an AI with the best query engine in the world isn't going to do that 100% correctly each time. So we take those code changes. We also generate a set of queries for what are the right tests that are associated with this, right? Either existing tests in the code base, or we'll actually create a set of unit tests on the fly that cover the functions and methods that Grit's going to have to update. Then we take both of those, both the existing tests, the unit tests, and put them into a sealed environment. We actually build a sandbox. We're using Firecracker VMs. Then we can actually build a sandbox where we intercept every external call that's being made, and then make those execute the code, right? See the test pass, mocking out things, because if it's just doing a code change, your external behavior shouldn't have changed, right? Your network level requests shouldn't have changed. The things that are actually going outside of it, we can mock all of those while continuing to iterate on the code base. Usually not right the first time. Then we go and actually have a language model look at the failures, right? We'll scan through a massive log of a bunch of failures. This is where any sort of static analysis techniques are also really helpful. And then generate a suggestion of what query would we use to fix those failures, right? So we're not going straight to code, because one thing you'll often see if you try to prompt a language model with a really long block of code, it'll start to say fill in the blank here, or fill it, or leave gaps, right? Everyone talks about GPT-4 getting lazy. That's one of the things that you can see actually with all language models is that they, the more context you try to give them, the less specificity it is. So we say actually, what's the very granular additional query you would do, so the additional transformation to fix this error, and then feed that back in. And this runs in a loop for hours or days, and then eventually gets to a valid result. Cool. So I'm just going to show how this actually works. Sounds cool, but want to make sure it actually works in practice. So if we go to Grit, I'm just going to make this a little bit bigger. We can log into Grit's web UI. We also have a VS Code extension and a CLI. Everything's accessible through there. I can do on-the-fly things. So I can say, maybe like everywhere that we're doing, we'll say A, we want to transform those, right? Or we can pull in any of our out-of-the-box things. So these are lots of things that we've done with hundreds of customers before. You can learn from the commons, see them in a preview here, right? So you can see it in a live environment before things are actually transformed. But it gets really interesting once we actually do it on our repo. So I'm going to select one code base right here. We'll do our secret shop here and run the analysis here. So this is going to, hopefully we have a network connection. The challenges with live demoing with things that connect to that. Okay, cool. There we kicked it off. Successfully went through. This is going to check out a repo into one of these ephemeral VMs, make all the changes that are necessary, and if we want to, we can just have it create a pull request for us. So this is going to go ahead and make a pull request into our environment. In this case, we're converting our test suite from chai to jest. And if we go over to it, it's going to take a few seconds to open the pull request. All right, so the pull request is up. I'm going to go to my repo here. And we're going to go to our secret shop. We've got a bunch of different demo repos. Here's our PR. It was converting from chai to jest. You can see here that Grit, what it did to validate it, all the changes that it made. But then the other thing we can actually do is start to give it feedback, right? So even if the AI wasn't following our best conventions the first time, we can actually ask it to tweak things. So let's say we don't like using 2B. We want our new standard to be 2 equal instead. So we can just say Grit agent use to equal. And Grit's going to take that feedback and figure out everywhere else in the PR that has to do that same kind of thing. Now, this PR looks good for the most part, but we also actually have to do all the validation I was talking about. So that comes when we actually have a migration. So this is one code base where we're migrating from JavaScript to TypeScript. The first pass that I was talking about in that architecture diagram is just the initial transformation, right? Where we like rename some files, do some static transforms, and then feed things into the Grit model. The whole healing step is actually where 90% of the time in this workflow is run, right? So that's where we actually, in a loop, we're going through this, executing compiler tests, executing things in the sandbox that I mentioned, in the VM sandbox. And it'll do this for a small code base, might take a few minutes. We've had PRs that actually took a week to generate because there are so many errors because the customer wanted to migrate literally 10,000 files at once. But Grit happily did it. It just keeps running in the background, sitting here. You can actually imagine, like, as a human, you'd be sitting here looking at every compiler error, looking at every linter, telling you what's wrong, and fixing it, right? But it'd be very monotonous, boring work. Grit's just doing that all in the background, right? It's just looking and seeing, all right, here's this failure. How do I fix that failure? Apply the fix for that failure. See if there's any more failure. It's not a super complicated process. Conceptually, the engineering of actually getting all the interception on tests to work and resetting the environment, which is where a lot of this comes in. But then it's able to apply those things. And if we go back over here to our PR, it should be updated here. Cool. So yeah, it updated with 2 equal as requested, right? So Grit was able to take that knowledge, and then any subsequent PRs that I open will have that same knowledge embedded in it, right? So I don't have to repeat myself to Grit. It's learned that rule, and it's now going to actually have that be something that it enforces for any PRs that it's opening. You can also use Grit to do analysis on other people's PRs too. So this is one of the things that, because we did that first initial one, I told it to use 2 equal, right? Grit's going to go ahead and analyze any other PRs that are coming in. We'll actually just show you, let's show our internal repo. We use Grit to scan all of our PRs as they come in. We run Grit checks, and Grit is doing everything that it's done before, figuring out, is there anything that's invalid there as part of that? So it plugs in more or less like a traditional static analysis tool would, except learning from the knowledge of every PR review that we've done historically, right? Not coming with a generic suggestions, not coming with an AI black box, but coming in with basically a shadow reviewer of the reviews that you've done. How would you do that to a new PR more quickly? Cool. We also do a lot of tracking. So for large scale code bases, we want to do things to actually understand if we are going to do a change across dozens or hundreds of PRs, what's the actual progress over time? So that's where some of these things come in. And actually, it's a significant factor for being able to do this for a large code base. But the ultimate thing that's most valuable for the PRs is the reviews there. We also intentionally designed it without latency, right? You notice that I had to switch to something else for a minute. You, of course, can use lower latency models, but they're less correct, right? If you don't go through the validation phase, you don't go through all of the biggest model that you can, you're not going to have as good of responses, right? So we actually tried to design the PR review around treating Grit like a PR, like a fellow engineer, right? So it's not going to give instant feedback. It'll give you 1 or 2 minutes, maybe 5 minutes. But during those 5 minutes, it can fully validate the change that it made, right? It's just not naively just applying the suggestion you made. So if you suggest it to do something that actually is going to cause an error, Grit will reject that suggestion and say, I can't do that, right? It's going to say that causes this TypeScript error, or that causes this unit test to fail, right? So yeah, would love to talk more about Grit. I'll be over there in the corner. Otherwise, really excited to share this with you. Thank you.